Let's move on to mean, median and mode. This should be a review for most of you. I think they teach this stuff in elementary school these days, but just a quick refresher now that we are starting to actually some realistic statistics. Let's just look at some actual data and figure out how to measure these things. So the mean, so you probably know, is another form of average. To calculate the mean of a data set, all you gotta is to sum of all the values and divide it by the number of values that you have. So let's take this example here. Let's say I went door to door on my neighborhood and asked everyone how many kids do they have, how many children live in their household. That, by the way, is a good example of discrete numerical data, right? Remain from the previous lecture. So let's say I go around and I found that the first house has no kids in it, and the second house has 2 children, and the third household has 3 children, 2 and 1, and so on and so forth. So I am this little data arrange of discrete numerical data, and to figure out the mean, all I do it and then sum and together divide by the number of houses. That in that case comes out to be 0 plus 2 plus 3 plus all and so on divided by the number of houses that I have looked at, which is 9, and the mean number of children per house in my sample is 1.11. So there you have it, mean. Now median is a little bit different. The way you compute the median of a data set is by sorting all the values and taking the one that ends up in the middle. So for example, if that was my original data set, I could sort it numerically and I could take the number that slap dab in the middle of the data, which turns out to be 1. So again, all I do is take the data and sort it numerically and take the center point. That's all there is to median. Now there is one nonce. If you have an even versus an odd number of data points, then the median might actually fall in between 2 data points, right? Like what? If I had an even number there of data point, it would not be clear which one is actually the middle. In that case, all you do is take the average of the 2 that to fall in the middle. So if you have an even number, you just take the middle 2. Now in this example, the median and the mean were pretty close to each other because they are not a lot of outliers. You know, we had 0, 1, 2 or 3 kids, but we did not have some wacky family that have 100 kids. That would have really skewed the mean, but it might not have changed the median too much, right? And that's why the median is often a very useful thing to look at and often overlooked. People have a tendency to mislead people with statistics sometimes, and I am gonna keep pointing this out throughout the course wherever I can. But for example, you can talk about the mean or average household income in the United States, and that actual number from last year when I looked it up was 72,000 some odd dollars, but that does not really tell an accurate of what the typical American makes. Because if you look at the median income, it is much lower. It is $51,939. Why is it? Well, because of income inequality. There is a few very rich people in America, and the same is true in a lot of countries as well. America is not even the worst, but you know, those billionaires, those super rich person that live on Wall Street or Silicon Valley or whatever, they skew the mean right. But there is so few of them that median so much. So this is a great example of where the median tells a much better story about the typical person. Of data point in this than the mean does. So whenever someone talks about the mean, you have to think about, well, what's the data distribution look like? Are there outliers that might be skewing that mean? And if the answer is potentially yes, you should also ask for the median, because often that provides more insight than the mean or the average. Finally, we will talk about mode. This does not really come up too often in practice, but you can talk about mean and median without talking about mode. I don't know why, because it starts with capital M, I guess, but all that is the most common value in data set. So going back to my example of number of kids in each house, if I just look at what numbers occur most frequently, it turns out to be 0, and the mode therefore of this data is 0. The most common number of children in a given house in this neighborhood is no kids, and that's all that means. So now this is actually a pretty good example of continuous versus discrete data, right? Because this only really works with discrete data. If I have a continuous range of data, then I can't really talk about the most common value that occurs unless I quantize that somehow into discrete values. Okay, so we have already run into one where the data types matters. Mode is usually only relevant to discrete numerical data. And if you have continuous data, not so much. A lot of real world data tends to be continuous. So maybe that's why you don't hear too much about this, but it's here for completeness. So there you have it, mean, median and mode in a nutshell. And we can move on. Open up notebook page here, and again if you do need a refresher on how to do that, head back to the setup lecture and I will show you how to do that. But once you have mean, median, mode open, we can play around with it. So let's see what's going on here. So what we are gonna start off doing is creating a fake data set of income distribution. So we are going to model 10,000 people and how much money they make each year. Now to do this, we are going to use the NumPy package. So like we talked about in importing package in our introduction to Python, we will start off by saying import NumPy as np. This allows us to refer to the NumPy package as just np, which just saves us some typing. In addition to importing that packages so that we can use it. Now the NumPy package includes a function called random.normal. And what this does is create a random distribution. Basically it creates a bell curve distribution of data around a certain point, in this case $27,000 with a standard deviation of $15,000. And we want 10,000 data points in this data set. Now if you are not familiar with the standard deviation and normal distribution, we will talk about that in more detail later on, but I think it will start to make sense of it as you go through this exercise. So once we have created that data set of 10,000 people that have a distribution center around $27,000, we can then call np.mean to use the NumPy package to compute the mean or average of that data set. And since we specify that it should be centered around $27,000, we should expect that to be about $20,000. So let's click into the block of code and hit shift enter to run it, and sure enough it is about $27,000. Now because this is a random component to this, your result may be slightly different, that's expected. That's okay, but it should be close to 27,000, so we can actually plot this to get a more intuitive feel of how this data is distributed. To do that, we are going to use a package called matplotlib, which allows us to create really simple graphs here in line and to actually display these graphs within the notebook file itself. We need to say percentage matplotlib in line as the first line here. Now if you ever run into a problem in the future with this course in the notebooks where you are not displaying it, probably because you forget to run a block of code that contains matplotlib in the file that is required to actually see these graphs. With that out of the way, though, we can import the actual matplotlib package itself, specifically the pyplot part of it. And again we will refer to that as an alias of plt just to save us some typing. So now that we have matplotlib pyplot installed, we can just say plt.hist to create a histogram of our incomes data set, and we are going to pass in the number 50, meaning that we want this split up into 50 different buckets. So we are going to quantize our data set into 50 discrete buckets of data, if you will, and then we can call plt.show to actually show it. Let's go ahead and run that as well. Shift enter with that block and you should see something that looks a little bit like that. So there is that bell curve that I promised you, right? And you can see that it's centered around $27,000. So if you are not familiar with histogram, the way to interpret this data is that a lot of people are making around $27,000 a year. Very few people are making between $60,000 to $80,000 per year. So that's the fictitious data that we can made up. So we have seen that the mean is about $27,000. That makes sense. That's what you would expect that. So again, the median is just, if we were to sort all this data, what would be the value in it all. And since we do have a nice even bell curve distribution here, the median should be about the same as the mean. Let's go ahead and click in block 3 here and run that, shift enter, and sure enough that's also about $27,000. So for an evenly distributed data set like this, the median and the mean will be about the same. However, not every data set is evenly distributed. Let's see what happens if we add Jeff Bezos into the mix, and let's say, just say that he made $1 billion in a day, $1 billion in last year, in 1 year. It's probably a little bit on high side even for Jeff Bezos, but just for the sake of argument, we are gonna call np.append to just append one extra value to the income list, and it will contain $1 billion. So we will have a new income list here that contains our normally distributed data plus Jeff Bezos income there. To mess things up now, remember the median just represent what is the middle value. If I were to sort them all, and we have only added one more data point here, so that should not change a lot of median. So let's run the median again, and we are still getting a value close to $27,000. So Jeff Bezos did not mess up the median of our data set. However, if we compute the mean, it's gonna be very different, right? That's up to $127,000 almost. So this is a great story about how an outlier in a data can set really mess up the mean or the average value of the data set. So when people talk about average or means, take that information with a grain of salt. Ask yourself, could there be outliers that are skewing that data, and income distribution is a great example. This. In that case, the median is going to tell you a better story about what's really happening in the larger population. So you know statistics lesson number 1, or how to watch out for people lying with statistics. Make sure you understand the difference between median and mean, and if there are outliers involved, the median is probably going to give you more useful information. We also touch on mode just because it starts with M and people talk about it together with mean, median for some reason. So let's go ahead and create another fake data set here. This will be evenly distributed. We will have a bunch of fake ages for 500 people. So we are going to call np.random.randint to have an even distribution of between 18 and 19 years old for 500 people. And then we will just type in ages, which allows us to visualize that array in line here. Shift enter within that, and this is a random, so we are gonna get different results every time. Now to compute the mode again, that is just the value that appears most often. So let's go ahead and do that. To do that, we are going to use the SciPy package and its states module, and it is just another way of importing it. So we are saying from SciPy import states. In this case we are not going to use this as clause, because I can type state that not too hard, and then we will call states.mode on the ages array to get back our mode result, and after that checks away for a little bit. It's a got to load up that package. We get our answer. Turns out in this instance the mode is 28, which occurred 14 times in this data set, and this is a completely random. So every time you run this you will get a different answer. Let's go back to block 7 here again and shift enter again to get a fresh data set here, and if we run this block 8 times again, and we should get a different answer. This time the mode is 20, which occurred so 15 times. So just shows you that the mode works, that this is random data, so it is not terribly meaning, but illustrates how you would do this. Alright, and there you have it, mean, median and mode. Let's move on to an exercise to let you practice with it. Gonna give you a little assignment here. If you open up mean, median exercise IPython notebook, there is some stuff you can play with. So I want you to roll up your sleeves and actually try to do this. So here we have some random e-commerce data. So what this data represent is the total amount spent per transaction. And again, just like with our previous example, this is a normal distribution of data. Just like our example can run that, and your homework is to go ahead and find the mean, median and of this data using the NumPy package. Pretty much the easiest assignment. You should possibly imagine all the techniques you need are on the mean, median, mode IPython notebook. My point here is not really to challenge you, as just to make you actually write some Python code and convince yourself that you can actually get a result and make something happen here. So go ahead and play with that. If you do have any trouble, post in the discussion and comment in our video lecture. So pretty trivial. If you want to play with that, feel free to play around with the data distribution here and see what effect you can have on the number there, and add some outliers. Outliers kind of like do what we do with the income data, so mess around that way